All right. Hello, grade. If you're in grade 9, you are in the right place at the right time under the right circumstances, okay? Because I'm going to have a session with the grade 9 learners, and hopefully, this session will be able to help any grade 9 learner who is passing by to actually have a very solid, well grounded understanding of the topic geometry, which you will be doing in term 3. Okay, please, if you are joining in for the first time, please double tap on the screen very hard so that we can get the visibility of this live going. And if you are joining in for the second time, third time, fourth time, please do drop me a hello in the comment section. I'd really appreciate that. If you are joining in for the fourth, fifth, sixth, or seventh time, then please be very interactive and visible so that we can be able to have a very good and wholesome time together doing the basics of geometry. Okay, are there any questions perchance or perhaps before I continue with today's lesson? Is anyone wondering about anything? Okay, no questions. All right. Then if there are no questions, then yeah, I greet you again. And like I said, this is going to be a live geometry lesson. I have already done a lesson on grade 9 geometry, like an introductory one. If you guys want to know more about that particular lesson, the introduction of it, where we looked at lines and angles, we introduced what an angle is, we looked at the different types of angle: acute, right angle, obtuse angle, straight angle, reflex angle, revolution angle. We discussed those like one by one. Then we looked at complementary angles, supplementary angles, and then we jumped into some of the properties of the angles that we will be looking at along straight lines. And we began to speak about some of the statements that are available in a document that we refer to as the acceptable reason document. So this acceptable reason document, we actually touched on some of the most important statements that are there. Statements that relate, of course, first and foremost to straight line, like a straight line, and what we ought to understand where the straight line is concerned. So the first statement there is, and this is where I want to start off from today, and then I want to pick up from there so that we can dive into some problems and we can get familiar with how to go about answering questions on Euclidean geometry where lines are concerned. So the statements I want us to look at are these ones. The first one, okay, because the first 10 statements in the acceptable reason document relate to lines. And so in grade 9, we need to remind ourselves what are some of the statements in geometry that relate to lines. So the first one that we need to be aware of is this one. The statement says the adjacent angles. Now this word adjacent, does anyone know in the comment section what the word adjacent means? Right. Please guys, do share this live. If you have friends, if you have a dog and a cat that are struggling with geometry, share the live with the dog and the cat that need the knowledge that may be missing on the geometry so that they can also have a chance. So anyways, and please double tap guys on the screen so that we can get the visibility of the live going. You know, we've got 30 likes there. You can see there in the corner, we've got 30 likes. So we can get the likes up. So it says here the adjacent angles. Do we know what an adjacent angle is? I hope we understand what the word adjacent means. So the word adjacent means next to. Next to. Okay, so the word adjacent means next to. So the adjacent angles, so angles that are next to each other, the angles that are next to each other on a straight line, that's what this means in layman's terms. Angles that are next to each other on a straight line are what? Are supplementary. All right, so if we have angles that are on a straight line, all of those angles on a straight line together added up, they are supplementary. They add up to 180, in other words. So this word supplementary is just another word that means they add up to 180 degrees. All right. So I hope we are together here. The adjacent angles on a straight line are supplementary. In other words, they add up to 180 degrees. Okay. Now, whenever, guys, we are using this sort of statement, we need to write our reason. And our reason is, and this is the reason that is on that acceptable document that is supposed to help us to have a common reason amongst all learners across the country. So this reason is angles on a STR. Now, STR means straight and then line. So we write straight short and we write STR. Okay, so whenever the teacher sees STR, he knows that he or she will know that you mean straight. This symbol here means angles. Okay, it's like a L, sort of like letter, but it's not really a letter L, but it looks like the letter L. And then you put S, that denotes angles. So angles on a straight line. So you just write this reason whenever you have to use this understanding. Okay, so this statement is always accompanied by this reason, and that's very important to note. Okay, so I repeat, the adjacent angles, in other words, the angles that are next to each other on a straight line, are supplementary. What does the word supplementary mean? It means they add up to 180 degrees, and this is the acceptable reason. Please take note, guys, of the acceptable reason that we use whenever we are using angles on a straight line. We write angles on a STR line. So if you look at this line ABD, you look at this line that connects B with C, and then you look at B1, in other words, angle B1 and angle B2. Angle B1 plus angle B2 together are angles that are next to each other, meaning they are adjacent. 2, they are lying on the straight line. And when you see angle C1, it's from this point of the line to there, and then B2 continues from this line to the straight line. So together, added together, because these angles, they complete a straight line, they add up to 180 degrees. So we can say angle B1, you see, take note of the cap, plus angle B2, take note of the cap, is equal to 180 degrees. And we write our reason. Angles on a STR line. We close the bracket. So our statement here is accompanied by the reason. Okay, let's look at this second statement. So please, guys, the first statement, I hope we understand it very well, that the adjacent angles on a straight line are supplementary. In other words, they add up to 180 degrees. These angles need to complete a straight line in order for us to say angle B1 plus angle B2. As we can see, angle B1 and angle B2 together, they complete a straight line. They're next to each other, add up to 180 degrees, and that is our acceptable reason. Okay, angles on a STR line. Move on to the second statement. Guys, I hope we understand the first statement. Are we good? Are we fine? Can I see comments in the comment section that confirm that we all are in agreement with the first statement and we understand what is expected of us? In the comment section, can I move on and we can explore the second statement, then the third statement, then the fourth statement, and so we can go. Can we go? Okay, thank you, Lesejo. I see very active in the comment section. Thank you for that. Okay, and if we look at the second statement says, if the adjacent, if the adjacent angles are supplementary, then the outer arms of these angles form a straight line. I repeat, if the adjacent angles are supplementary, the outer arms of these angles form a straight line. Okay. Now I want you to note, guys, this statement. It's a very important statement. And if you look at the reason, they write ADJ, which stands for adjacent, angles, obviously with the symbol that stands for angles and the S, and then SUPP, which means supplementary. So adjacent angles sub is a reason that we utilize whenever, as it says, if the adjacent angles are supplementary, the outer arms of these angles actually do form a what? A straight line. So this statement number 2 is a statement that we usually are utilizing in order to prove that a line is straight. And I'm sure people are like, but aren't all lines straight? Well, that's a very good question. Are all lines straight? All right. And it seems like in order for a line to be considered straight, what has to happen? The adjacent angles need to be supplementary in order for us to conclude that the outer arms of those particular angles actually do form a straight line. So in order for us to prove that a line is straight, we need to prove that the angles adjacent on that particular line have outer arms that actually form a what? A straight line. So in order for those outer arms to form a straight line, the adjacent angles need to have been what? Supplementary. So this is the reason we use whenever we prove that a line is a straight line. So take note of this. We have A, C, B. And the immediate question I may ask you is AB a straight line? Now I'm sure when you guys look at AB, you look at it and you're like, Haibo, sir, hey, why now are you asking that question? How can you ask that AB is a straight line? Can't you see, sir, that AB is not a straight line? And maybe that can be your conclusion, that AB is not a straight line. Then we are going to have to look at this line AB in light of the statement that is here. And the statement is saying if the adjacent angles are supplementary, the outer arms of these angles form a what? A straight line. So let's look at this. On AB, we have this angle, okay, C1 and angle C2. Angle C1 is 50 degrees. It's from here up until there. Angle C2 is 130 degrees. It is from this point to there. If we add these two angles that are next to each other, what is 50 plus 130? That's my question to you. So in other words, if I'm going to explore and say angle C1 plus angle C2, what is angle C1 from the statement? From the diagram. Angle C1 is 50 degrees. What is angle C2? Angle C2 is 130 degrees. And my question is, what is 50 plus 130? Does anyone know what is 50 degrees plus 130 degrees? Anyone care to assist me? What is 50 plus 130? Okay, thank you. Seems like Lesejo is the only one on loudspeaker here. So 50 plus 130 is 180. Thank you, Beauty, as well. So 50 plus 30 is 180. Now the two angles that are adjacent to each other are adding up to 180. So according to this theorem statement, what is this saying? If the adjacent angles are supplementary, what does that mean? It means the outer arms. What are the outer arms? The outer arms are AC and CB. The outer arms of these angles form a what? A straight line. So what does that mean about AC and CB together? ACB is actually a what? What is ACB? If the adjacent angles C1 and C2 are supplementary, what are the outer arms forming for us? They form a what? Guys, what are they forming? I'm sure you guys can see that. They form a what? So ACB is actually a what, guys? What is ACB? ACB is a It's a straight line. Okay. And what reason do we have for saying that? The reason is very simple. Here it is. Adjacent angles sup. Adjacent angles are actually what? Are supplementary. They add up to 180 degrees. That's why we can conclude that ACB is a straight line. All right. So what looks like not a straight line, in actual fact, in reality, is a straight line. And that is something that you need to note very strongly. Okay. So that is statement number 2 from the acceptable reason document. We use that statement number 2 of the acceptable reason document to prove that a certain line, whatever line it is actually a line that is straight. So I'm going to repeat this again. Statement number 2 says, if the adjacent angles are supplementary, the outer arms of these angles form a straight line. I repeat, if the adjacent angles are supplementary, the outer arms of these angles form a straight line. Very important statement used to prove that a line is straight. Hello, Sivu. So, like I said, and I repeat, is ACB a straight line? When you look at it, well, when you look at it, you're like, there's no ways that this is straight. But can we prove that ACB is a straight line? Well, let's check out the adjacent angles. Angle C1 and angle C2. What's angle C1? It is 50 degrees. What's angle C2? It is 130 degrees. What is angle C1 plus angle C2? Well, angle C1 is 50. Angle C2 is 130. When I add the two together, I get 180 degrees. What does that mean? It means that when I add my two adjacent angles, I get 180 degrees. If I go back to the statement, what did it say? If the adjacent angles, meaning angle C1 and angle C2, which are angles next to each other, are supplementary, in other words, if they add up to 180 degrees, what can I conclude? The outer arms, what are the outer arms? AC, which forms angle C2, and CB, which forms angle C1. What about the outer arms? The outer arms of these angles form a straight line, which is why I can conclude that ACB is in actual fact a straight line. Doesn't look like it, but you know what? ACB is a straight line. It is. Why? Because the adjacent angles are supplementary. Therefore, we conclude ACB is a straight line. What's the reason? Adjacent angles sub, meaning the adjacent angles are supplementary. Okay, I hope that is clear for all that have just received this statement number 2. I'm going to move on to the third statement in our acceptable reason document for grade 9s. The third statement says the following: the adjacent angles in a revolution, I repeat, the adjacent angles in a revolution add up to 360 degrees. I repeat, the adjacent angles in a revolution add up to 360 degrees. What does the word revolution mean? The word revolution means around, circle. When we say around and we say circle, when we think about circle and around, we think about all the way around, which means the angle definitely add up to 360. Okay, so the acceptable reason, angles around a PT. PT means point. This is short for angles around a point. This word here is shortened for point. Or we can say angles in a rev. Angles in a rev. So I hope that is clear for you, grade 9s. All right, that if we are talking about the adjacent angles in a revolution adding up to 360, the acceptable reason we use can either be, okay, angles around a point, angles around a PT, or angles in a rev. Okay, that is very, very important. All right. Okay, so I don't know if anyone has any question about angles around a point or angles in a rev, but that is simply just it. And if we look at this here, this is a visual example of what we mean by angles around a point. We have a point here, and as you can see, this point is point P, all right? With point P, there's angle P1, which starts from here up until this line. There's angle P2, which is from here up until that line. There's angle P3, which is from there up until that line. We have angle P4, which starts from here up until that line. And then we have angle P5, which starts from there up until that line. So if you can see, we have literally moved around in a circle 360 degrees. So if we're looking at P, angle P1, angle P2, angle P3, angle P4, and angle P5, these are all angles that are next to each other. So in other words, what can then we conclude? We can add these 1, 2, 3, 4, 5 angles together. And what do we know based on the statement? That the adjacent angles in a revolution add up to 360 degrees. So that's why we can say angle P1 plus angle P2 plus angle P3 plus angle P4 plus angle P5 and are equal to what? 360 degrees. Angle P1 plus angle P2 plus angle P3 plus angle P4 plus angle P5 is equal to what? 360 degrees. What's the reason? We can use one of two reasons. We can either say angles around a PT point, or we can say angles in a rev. These are the two acceptable reasons, according to the document that I shared with you, that we can utilize whenever we are having to use this particular approach in order to actually solving an unknown, where angles obviously around a point, they add up to what? 360 degrees. Okay, I hope we are together. Okay, then let's look at statement number 4, which also relates to lines. The statement number 4 says vertically opposite angles are equal. So whenever we have two intersecting straight lines, and this is very important, two intersecting lines, and those lines are straight, they intersect. Intersecting lines are typically lines like this. For instance, this line, if it's a straight line, and this line, if it's a straight line, we would call these two lines intersecting. The word intersect means cut through or cut across. All right, so this line here is cutting across this line. And please guys, the assumption here is that this is a straight line and that one is also a straight line, even though they've been drawn freehand and it might not look that they are. Okay, so when you are looking at these, you are looking at two straight lines, which means these two lines are intersecting at this point. They are cutting across each other at that particular point. So what is this then saying? It's saying that vertically opposite angles are equal. Now I want you to note, what is a vertically opposite angle? In other words, if this is point M this point, then angle M1 and angle M3 are what we refer to as opposite vertically. Okay, so vertically opposite. Angle M1 is equal to angle M3. Okay, angle M1 is equal to angle M3. So that's why we can say here angle M1 is equal to angle M3. And the reason we utilize is vert, op, angles equal. Very short, vert for vertically, op for opposite, angles, and then equal. All right. So I hope you guys understand now this whole op thing. Okay, I know that on TikTok they use a new op on the list alert. I don't know this. I think it's that rainfall in Durban guy who usually uses that new op on the list alert. I don't know specifically why specifically that guy uses op, but maybe you guys know. But nonetheless, here in this situation, we are talking about two angles that are opposite each other. Okay, so angle M1 and M3, we don't call them adjacent angles, we call them opposite angles. They are vertically opposite. In the same vein, angle M4 and angle M5 are also vertically opposite angles. So we can say angle M4 is equal to angle M5. And the reason is vert, op, angles equal. Okay. So I don't know if there's any questions specifically about these statements that we have just looked at. Okay, so we looked at the examples then last time just to sort of like make sure that we're all on the same understanding when it comes to these properties. So if you look at angle M1, if we look at these properties and these theorems, example 1, find the letter X giving reasons. Okay, so here we have it. If you look at the diagram, we have line A, B, C. We have this line, which is BF, and we have X here, and we have 84 degrees. And so they are saying find the letter X, and we need to give a what? A reason. So if we look at X, it's a angle, and it's from here, the straight line, up until this line. If we look at 84 degrees, it is a angle from this point of the line up until the end of the straight line. So it means angle X and angle 84 degrees are angles that are lying on the straight line ABC. And so as angles that are lying on the straight line ABC, they complete the straight line because angle X is from here to here. Okay, so it's from the straight line to here. And then this angle 84 degrees is from this line back to the straight line. So therefore it means angle X and angle 84 degrees, they are on the straight line and they complete the straight line. Therefore we are well within our right to say X plus 84 degrees is equal to 180 degrees. I repeat, X, which we don't know, plus 84 degrees, which we know, is equal to 180 degrees. Where is this coming from? It's coming from the fact that we know these, according to the reason that we spoke about, are angles on a straight line. Now I want to send you back to the theorem statement. What did the theorem statement say? It says the adjacent angles, in other words, adjacent means angles next to each other, on a straight line are what? Are supplementary. In other words, they add up to 180 degrees. And when we use this, we usually say angles on a STR line, brackets. So look at what we just did here. X plus 84 degrees is equal to 180 degrees. This is our statement. And it has a mark. All right, the statement which forms an equation has a mark. Then it's followed by our what? By our reason. What is the reason for saying this? Angles on a straight line. It also has a mark. Then after that, we know how to solve a linear equation because we did that in term 2. So we have x plus 84 degrees equal to 180. We want the value of x. We take 84, we transpose it to the right hand side. When 84, which is positive, goes over to the right hand side, joins this term, it becomes negative 84. Then we say 180 minus 84. We know that 180 minus 84 is equal to 96. So therefore x is equal to what? 96 degrees. All right, and that's that. Our third mark. We are well on our way to getting sweet marks for term 3. All right, okay. I think that's straightforward, guys. Okay, let's look at example 2. Example 2 has the following. Please ignore this 58 degrees that is green, because this was an example that I did the last time I was live. Okay, so we have the x, we have y, we have 58, we have y. So we have how many unknown angles? We don't know what y is, we don't know what x is. We want to find the letter x and we want to find the letter y. So from the get-go, you can see that we have what? 2 lines that are intersecting each other. And these lines, as they are intersecting each other, we can see that there's a relationship between this 58 degrees and this x. Why? What type of angles is x and 58 degrees? What type of angles are x and 58 degrees? What relationship does x and 58 degrees have? All right. Can we see the relationship, guys, that exists between x and 58 degrees? Because at the moment, we cannot associate any other relationship with x and y at the moment, because if we were to associate a relationship with x and y, we don't even know what y is and we don't know what x is. So to have an association of a relationship with x and y at the moment is not going to help us to find the answer. Rather, we can see that x and 58 have a relationship, and this relationship can lead us to an answer. This x and this y currently do have a relationship, but unfortunately, the values that we don't have for x and y cannot lead us to a specific answer. So if we look at x and 58, it seems like this relationship will lead us to answers. And you always want a relationship that will lead you to a what? To an answer. So x and 58 degrees have what kind of relationship? These lines are intersecting and these angles are actually what? If we go back here, vertically opposite angles are what? Are equal. So remember we said angle M1 would be equal to angle M3, vert op angles equal. We know that angle M4 would also be equal to angle M5, vertically opposite angles equal. In the same way, x and 58 degrees, what type of relationship do they have? These two angles are vertically opposite. So therefore, what do we say? We can say that x is equal to 58 degrees. What is the reason? Vert op angles equal in brackets. So this is our statement. All right, and it's 100% correct. And this is our reason. It is also 100% correct. All right, and it is according to the acceptable reason document that we wrote. Okay, so I hope that makes sense. Okay, now let's come here. Now that we have this angle, which is 58 degrees as well, we can now go ahead and try and find what? The value of y. Now, since we've gotten 58 degrees, we then come to our diagram and we update our diagram with the new information that we have received, so that we can make sure that when we look at the diagram again, we can look at it and still now be able to relate what we have with something else. All right, so 58 degrees, we can now update. That's 58. Now we want the value of y. So y and 58 degrees also have a relationship, but x and y have a different relationship with x and 58. What kind of relationship does x and y have? And I'm sure, guys, if you are looking very closely, you can see that this x, which is 58, which I've found, and this y are two angles that are what? They are next to each other. In other words, they are adjacent. Okay, and they also lie on a straight line. So what do I know about two angles that are adjacent and they lie on a straight line? What do I know about two angles that are adjacent, in other words, that are next to each other and lie on a straight line? If you go to the theorem statement, we know that adjacent angles on a straight line are what? They are supplementary. In other words, they add up to 180 degrees. Very good. Let's say in the comment section. So therefore, we can then say the following. This 58 degrees that we have plus the y is equal to what? 180 degrees. Is the statement true? Oh, definitely it is. If we look at the diagram in light of this straight line and we say 58 plus y is equal to 180 degrees, that's absolutely true if we're looking at this straight line. Someone else who's looking at the same diagram may be looking at this straight line and may be looking at y and 58 degrees and saying these two angles are also what? Supplementary. They add up to 180 degrees, which is 100% correct. So therefore we can say y plus 58 degrees is equal to what? 180 degrees. And our reason can be angles on a straight line. So I'm sure, guys, well, it depends. You are looking at the diagram in which angle. Because if you are looking at it this way, you can see angles on a straight line. If you're looking at it this way, you can see angles on a straight line. Because these are two angles that complete a straight line and they add up to 180 degrees. So that's beautiful. So we say y plus 58 is equal to 180 degrees. That is a statement. And that statement is correct. If we look at the reason, it is beautiful. It is according to the acceptable reason document. Then we can solve for y. And guys, our knowledge from term 2 helps us very nicely because we have just freshly learned how to solve for an unknown, a linear equation. So we transpose the 58 degrees. It is 180 minus 58, and then 180 minus 58 gives us 100 and what? And 22 degrees. And that's that answer. So the y value, guys, is actually what? 122 degrees. We can then update the diagram and obviously know what the answer is. Someone else who's looking at the very same question could probably then say to themselves, you know what? I am seeing another relationship. Maybe someone does not see the straight line relationship. What they see is they can see that 58 degrees, we got it, Moss, from vertically opposite angles. So when we update the diagram, 58 degrees is there. There's the y there, there's the y there. These are vertically opposite angles. But what they can see all together is the following. They see this 58 degrees. They see the y. They see the 58 degrees. They see the y. These angles, 1, 2, 3, 4, 1, 2, 3, 4. I'm sure you can see 1. Connect 2. Connect 3. Connect 4. This completes a what? A circle. A complete what? Revolution. And because I only have one single variable y, that is my unknown, and I know this is y, this is also y because these are vertically opposite angles, then it means I can just add all 4 angles. Okay? They are next to each other. Y plus 58 plus y plus 58 degrees is equal to what? 360 degrees. Why can I say that? Y plus 58 plus y plus 58 degrees is equal to 360 degrees. That is my statement that I can utilize. The reason, angles around a point. And you know what, guys? When I solve this for y, I actually get the very same answer that I got when I used angles on a straight line. I get y is equal to 100 and what? 22 degrees. So all in all, you are seeing that there are diverse ways of being able to find an answer when it comes to geometry. So when we know our statements, guys, when we know our statements very well and our reasons, I'm telling you, one person could go one way, you could go a completely different way. Right. Now I'm going to actually now invite you guys to answer these for me. This is the first one. If you feel like you can answer this for me, please, you can request to join there in the guests, and we can chat about it. You know, more than just comment in the comment section and give me answers. Please, guys, it would be nice if we can engage in discussion. All right, please use the guests. If hopefully you can, you have the environment, you can speak, you can, you know, your parents can allow you to chat to me. You can, you know, request, and we can chat about it, and you can let me know. So the question is saying calculate the size of the small letters and give reasons. So we're going to look at this first one. This is 63 degrees. We have this line and that line, and this is the A, the small letter. So I want the value of A. All right, please, guys, and it says calculate the size of the small letter, give reasons. So what I want, more than just give me the answer, I want people to actually engage and chat to me about how would we go about finding the value of A. All right. Now, anyone who wants to engage, especially if you're in grade 9, guys, because this is a grade 9 focused lesson more than anything else. If you're in grade 10, 11, and 12, of course, I mean, I'm not saying you should leave the live. I'm sure you will probably just see that, oh, this is what I know anyways, you know, maybe solidify your basic understanding of lines and angles. But this is more geared towards the grade 8s and the 9s. The grade 8s as well, this is content for you, because grade 8s in term 3 also do the same geometry that the grade 9s do. Grade 9s do a little bit more than the grade 8s, you know, there's added things which we'll go into later on. But for now, this is kind of the basics that you guys start off on. Okay. So here we have it, 63 degrees, that's A. What is the value of A, guys? Anyone? Anyone who wants to be anyone? Okay. Okay, so remember what I want here is more than just the answer. Remember, there has to be a reason that accompanies your answer. And what I want is like, if you want, you can always just request there. We can chat about it, or I guess, yeah. Okay, so Nuri, I see you've written 117. Okay, which I'm guessing you are saying the answer is 117. What does everybody else have to say about that? Okay, so hopefully we can see that that's a line, like I said. All right, and then there's another line here. So A and 63 degrees, they both lie on a straight line. Okay, so I'm sure you guys know that there's a relationship that exists between this 63 degrees and this A. What is that relationship? A and 63 degrees, what's the relationship that exists between these two angles? Okay, they are adjacent angles, meaning they are next to each other. And as adjacent angles, all right, if we are going to check, yes, they are adjacent angles, right? So indeed, if we look at that angle, it comes from this line to that one, and then 62 degrees completes the what? The angle, so that it is up until the line itself. So these are both angles that are next to each other, and they complete a straight line. It's very important, guys, that the angles complete the straight line. When they do, that's why we have power to then say, we can say the statement A plus what? 63 degrees is equal to what? 180 degrees. And what's our reason? Remember, from the acceptable reason document, now we want to really, be on point when it comes to this. In grade 9 already, we don't want to be, writing different reasons or reasons that basically are too general. We want to be specific because we know there's a working document that they work with in grade 10 and 11. So already we want to be on point when it comes to that document. So the document says, if we are saying a plus 63 degrees is equal to 180 degrees, our reason that is concise, that is uniform, that is accepted is angles on a STR line. We stick to that. I will never lose. Okay, we'll never lose. So that means our statement is 100% correct and our reason is 100% correct. Now we can go ahead as a grade 8 and a grade 9 learner. We can then go ahead and we can solve for the unknown A. So then what do? We take that 63 degrees, we transpose it, and it becomes negative 63 degrees. Okay, and then what's 180 minus 63 degrees? I'm sure you guys can see it. 180 minus 63 degrees then gives us what? Bella, you're funny. 117, guys, degrees. Let's be very careful with that, because imagine making an error when it comes to the addition and the subtraction and writing 118, for instance. Then goodbye our final mark for the answer. You see, there's a mark for a statement, a mark for the reason, because the reason is also important. No reason, then means you lose that mark. And then there's a mark for the answer. Okay, 3 marks. Okay, yeah. Let's look at the second question. Here it is, guys. Look at this diagram. Let's study it as well. So we have a line, okay? Then we have this block here. What does this block mean, guys? What does this mean? Then we have 29 degrees. Okay, 29 degrees is this angle from there to there. X is that angle from here to there. Then we have 90, which is from here to there. What does this block, or what does this stand for? What does this symbol mean, guys? Do we know? This is a symbol that means something. Okay, and imagine if we don't know what that symbol means, then it means that we're not going to know what to do in order to solve for X. Okay, thank you so much there in the comment section. Lesego says right angle. And right angle, what does right angle actually mean? It is equal to 90 degrees Kuli. So thank you so much. So tag teaming there between Lesego and the Kuli. So, and then HY Gamer also is saying 90 degrees. Okay, so I want to solve for X there, guys. So how do I go about solving for X, and what is the reason? What do I do here? Okay, so we have this line again, right? What do we do? I'm listening. So I'm hoping you guys have pen and paper out and you're doing the things. And like I said, statement, reason, answer. As you can see, the mark allocation here is very rich, but it is rich, and the marks are awarded, in grade 8 and 9, as we make sure that we write the statement, we write the reason, and then we calculate and get the accurate answer. Okay, then we will never be at loss of the mark. The marks will always be awarded to us. So let us make sure we are precise You're done solving, Kulis. Okay, so what did you get, Kulis? What is your value of x then if you are done solving? Okay, and anyone else who's done solving? That's neat, that's fine, it's good. Okay, hopefully the reason as well is appetizing, it's appetizing. Okay, Babska forever. Okay, I see. Sesam got 61, Sesam got 61, Kuliso got 61, Lesejo got 61. Seems like you all got the same value. Great, amazing. All right, thank you so much, guys. All right, so I'm guessing you can see the relationship there. 90 from here to there, 29 from there to there, x from there to there. They complete a straight line. That's very important, guys. The completion of the straight line. So therefore, because we complete that straight line, it means those are angles that actually they add up to 180. So we can say x plus 61 degrees plus 90 degrees is equal to 180 degrees. Then our reason, hi guys, straightforward, angles on a STR line, straight line. Okay, then we go ahead and we solve. X is equal to 180 minus 90 minus 61 degrees, and then we solve that. We get the value of x, 180 minus 90 minus 61 degrees. 61, 29. What am I doing? Seems like someone got what is it? I think I got you guys confused me with your 61 answer. So now I ended up writing 61, but you know what I mean, 29. So let's just fix that with a pen, because the pen will be more powerful and more authoritative, So x is equal to what? 61 degrees when we solve. Okay, I'm sorry about that 61 that I utilized there. We have got our statement, we've got our reason, we've got our answer. I think I got caught up in your 61 degree answer. It was the last thing I said, so therefore now I started applying it to the actual calculation. So make sure x plus 29 plus 90, those all add up to 180. We have our reason there, which makes sense and it's correct. And then now we're working out x is equal to 61. Okay, so well done, guys. You guys are on the money. Here's another one for you. Do this one. Here it is. This is 2y. We want to solve for y, giving reasons. 48 degrees, 52. Let's go. Let's go. We've got 2y, we've got 48 degrees, we've got 52 degrees. So once again, solve for y, giving reasons. Sesam is so fast, eh? You're too fast. Fast. It's like you're off the blocks fast and it's like poof. Kulis was also done. Great. Okay, I love how swift we are moving. That's great, people. I love it. I love it for you. I love it for yourself. Okay, so I'm guessing you guys have gotten the answer, and the HY gamer there seems like already punched in there, in the place of y, what the value of y is. Okay, so what did we get since we're done? Okay, 40 degrees on the money, okay, on the money, yeah. Okay, nicely done, guys, nicely done. Okay, yeah, so when we show our working out, it becomes important that we write out what we got. So I'm guessing you all know that these angles, they are angles. Once again, if you look at 2y, we need to check, do they complete a straight line? 2y from there to there to 48 degrees, there to 52 degrees. If you look at the entire angles next to each other, do they complete the straight line? Definitely they do. So therefore, what do we know? 2y plus 48 plus 52 should give us our what? 180 degrees. So 2y plus 48 plus that 52 degrees should give us a what? 180 degrees. That's our statement. The reason: angles on a STR line. Okay, angles on a straight line. Then we can go ahead and solve for y. And very nice, when we solve for y, we can just say 2y is equal to, we transpose everything else, 180 minus 48 minus 52 degrees. And of course, minus 48 minus 52 degrees, that gives us a negative 100. So I've got 180 minus 100, we get 80. Then we divide both sides by what? By 2. That gives us y, which is equal to 40. So you guys are 100% spot on. It is 40 degrees. Okay, statement, reason, boom, answer. Okay, nice answer. Okay, and our working out is spot on. All right, any questions, guys? Any questions? Okay, I think you guys are flowing very nicely. Now. This is important here. Yes, Kulis, so go ahead. Quick question. You can go ahead, ask your question. What's your question, Kulis? Okay. Before I go on to the next few bunch of questions, because the next bunch of questions will obviously relate to another portion. If I say angle on a straight line add up to 180 degrees, Kuliso, you can go ahead and say that, right? I don't think there will be any particular, maybe your teacher won't be too particular with you if you are in grade 8 and 9, to be honest. But me, I'm not going to lie. With my learners at school, I do not even give them that, I don't even give them that space to utilize any other. Because remember, if I have a learner in grade 9 that is saying they want to do pure maths in grade 10, what I want to do is I want to make sure that I instill this fundamental way of being able to write your reason. Why? Because in grade 10, 11, and 12, it's kind of like the rule, right? Grade 10, 11, and 12, there is a document that informs the reasons that we write. Okay, so let's stick to those ones. All right, like I said, it will depend on your teacher, because you'll get at school, for instance, your teacher may not be too particular, but me, I'm very particular, right? And so yeah, the acceptable reason document reasons, I stick to them from grade 9 level. In fact, from grade 8 level. My learners know from grade 8 level, we roll with these. I will roll with them, we roll with them. So let's roll with these, okay, so that we can have that uniformity there. But thank you for asking the question, Kulis. I mean, it's good that you asked the question, because I think, generally speaking, I mean, I'm sure, Kulis, so if you are a grade 8 learner, you're coming from grade 8 and that's how you were doing it, like I said, there seems to be no sometimes in grade 8 and 9 we tend to be not as strict, but me, have changed my way of working. Grade 8s and 9s, I'm very strict with the statements. The reasons need to be sort of like the way that the document says, so that they can get used to it already. They go to 10 and 11 and they don't have problems with writing the right reasons. Okay, let's look at this part now of the questions. This question is saying, is PQR a straight line? So let's look at this diagram. The question is asking, is PQR a straight line? Why? Is PQR a straight line, and why? Okay, so we want to look at this and we want to figure out, is PQR a straight line? So this is P, Q, and R. Okay, and we want to figure out, is PQR a straight line, and we want to sort of like, you know, also support why. Okay, all right, and let's say Jose says yes, the angles add up to 180 degrees. It's Chris says the same. Yes, it is a straight line. Okay, I think the reason though is kind of given by, let's say that